start with, so let's break down this test. There's 5 no calculator multiple choice, there's 5 calculator multiple choice, and there's 1 no calculator FRQ. So I had to get creative with how I did this. So you're going to have, when you first come in, you're going to be starting with number 6, which is what I'm going to start with here in a second. Guys, no talking. So I'm going to start with number 6. You'll have a little bubble sheet for these 5 problems. You'll turn that in, and then you'll get the non-calculator on one side of your answer sheet, bubble sheets, and on the other side is the FRQ. All right, because that's no calculator. And you'll just put your calculators on the floor like we've done before. All right, so calculator portion first, like I said. Also, if you're turning in your project tomorrow, some of you have turned it in early. Maybe you have it today and are going to give it to me. It's not due till tomorrow, so totally fine if you don't do it till then. But as I said before, remember, tomorrow's a test day. Tomorrow is not come in, ask to borrow some markers and colored pencils. Oh, can you check my graph? Does this look good? Is my name in the right place? That needs to be done.
Good afternoon once again. This will be the last interruption to remind everyone that this is not a watch this tornado warning. All students need to be in classrooms in the duck and cover position. We should not have students wandering. We should not have adults wandering the concourse at this time. Please ensure your safety of your students and yourself.
Go ahead, Ty. I know you're scared. It's okay. We're not going to laugh at you. She said duck and cover. No, she said just stay in the classroom. Okay. Shh. All right, guys. All right, let's go. So let's get started. So like I said, I'm going to start with number 6, do the FRQ, then I'll just answer any other questions you guys may have. All right, so number 6, and I am recording this, so if you need it later, you guys can tell Bishop to watch it. Hey, Bishop. Still doing his thing. All right, so in number 6, we have rectangular coordinates given to us, right? That's x and y, and we have to change it to r and theta. We have 2 formulas that do this, and you have to know them. These are the same 2 formulas you used in number 3 yesterday. There's just one difference in that you can use a calculator on this one, and you have to use a calculator on this one, and I'll show you where. So you can sketch the graph of this point to draw the triangle, or just know what quadrant it's in, just to make sure you guys understand. If I graph the point -4, 7, that's going to put my triangle, my angle, my theta, whatever, in quadrant 2, because I go to the left 4, up 7 to get to that point. And so I know I'm in quadrant 2. And this formula is just Pythagorean theorem, okay? We have 2 legs of a right triangle. We're trying to find the hypotenuse. So we would square each of those numbers. You're using your calculator, and you get the square root of 65, okay? Now, one of the things we're going to talk about a lot over the next month is smart calculator taking strategies, or test taking strategies. And one of them with multiple choice is not to only read the question, but to scan your answers. Because, you know, our tests are timed, right? In class or on the AP exam, you have to get your test done in class, and on the AP exam, it's timed. When I see, if I were taking this test tomorrow, and I notice that all my R's are the same, I wouldn't even bother with this, okay? I'm not asking you to show work. I know some of you are perfectionists, you show everything. I ain't looking at it. The graders aren't looking at it when you do your AP exam. So if you can get away with not doing as much work, yay for you, okay? And that's a great test-taking strategy. It's not cheating, all right? So, but we know how to do it if we need to decipher between a few of them. All right, the other one, this is sine over cosine, one of the ones you had to memorize, y over x. This would be 7 over -4. And this is the reason you need your calculator right here, is because when we did number 3, when we did tan is y over x, we got -1 here, which is one of our memorized tan tricks. Anytime we have a 1 or a -1, it's a denominator of 4, and we came up with what quadrant it was in and all of that. This one is not one of our tan memorized standard angles, so we are going to put it in our calculator. Now remember, we're trying to find theta. Anytime you're trying to find theta, you have to use the second button, It's inverse tan or arctan. So second tan, and then putting in 7 divided by -4. It doesn't really matter where you put the negative. And we get this. Blah, blah, blah. Okay? Now, the answer to this is not B. No, it's not B. Here is why. This is the part I told you guys why I was going to do this problem with you guys today, because I knew I would have to explain it a lot, so let's do it all at one time. I'm going to have to go to another piece of paper to kind of explain this to you. Back at the beginning of this unit, we graphed sine and cosine and tangent, and then we learned about their inverse, the inverse of these, and we had to switch the x and y's, and it didn't pass the vertical line test, so we restricted the domain. And what ended up happening is when you have inverse sine or inverse tan, you are using only 2 quadrants of the unit circle. If you remember, cosine was sunrise. So we only used quadrant 1 and quadrant 4 and for inverse sine and inverse tan. And that's what your calculator does too. Your calculator does a lot. We talk about this a lot. It can do so much for us, but it doesn't know what quadrant we're in. Like we just put in some numbers and it gave us an answer. It's giving us a negative answer, which is quadrant 4, but we also get negative answers in quadrant 2. Remember, all students take calculus. So we're negative here and positive here and here. So you can only get 2 things on your calculator. What we just found was a negative, but we know we're not in quadrant 4. So let me back up. We know our angle is in quadrant 2, okay? This is the answer for quadrant 4. Anytime we need to find quadrant 2, and we're in quadrant 4, we have to add pi, because that's half a unit circle away. So we're adding pi, which gets us on your calculator this number right here, okay? Now, what if I got a positive answer in my calculator? Well, that would mean I'm either in quadrant 1 or quadrant 3. So if I knew my angle was in quadrant 1, I would just take whatever is in my calculator. Just like if I knew my triangle angle was in quadrant 4, I would take whatever's in my calculator, okay? So if I get a negative, it's going to be one of these 2. If I get a positive, it's one of these 2. And then you just figure out, is my angle in that quadrant? If it is, 1 or 4, I just keep whatever I got here. If it's in 2 or 3, either way, I have to add pi, okay? So you have to remember that. That's why it's super important for so many different reasons to know what quadrant we're in. In number 3, we knew to use 7 pi over 4 because this point was in quadrant 4. To the right and then down was quadrant 4. That's how we chose our numerator here. Okay, so there was a little bit of skill involved there, just like on this one. Okay, so remember that. That can be an easy one to get wrong if we're not careful. Let us go to BF part Q. I'm really glad that I'm doing this with you guys because I cannot explain to you how many people have struggled with making this chart today. Like a lot. And this is the Algebra 1 part of it. Okay, so let's make sure we pay attention to this because what people lost their minds over today was that you couldn't use a calculator. How am I going to do this without a calculator? Because we've done a few of them with a calculator where you would type this in, go to your table of values after you changed your table to count by pi over 6, and you just filled in the blanks. Okay, how do we do it if there isn't a calculator like is going to happen tomorrow? So we have to do it by hand, algebraically. So we have this equation, 4 minus 4 cosine theta, and they have pre-filled in our thetas for a table of values. We have to plug each of these table values in for theta and simplify. So take a second, just a second, on the test day, and look at your what you have in here. And what we have are all the quadrantals, 0, pi over 2, pi, 3 pi over 2, and 2 pi, and we have our denominators of 3. Okay? We don't care about denominators of 4. We don't care about denominators of 6. So I'm just throwing out to you right here if I were taking this test, what I would do. Completely optional. I would take the extra few seconds to draw myself this diagram because I'm going to be plugging all the cosine values in a second, and it's going to be so much easier if I'm just looking at them right there. Also, I'm going to have to know all my denominators of 3, but just cosine. And remember, cosine is the first part of an ordered pair, and all of my denominators of 3 have a 1/2. I don't even care about that one. I don't even need to take time to write it. I'm not going to use it for anything, okay? One more thing that might help is this, because as we go into quadrant 2 and quadrant 3 and quadrant 4, we're going to toggle between positive and negative, okay? So having that is going to make my life a little bit easier. Now, I'm going to show this with a lot of work, and then I'm going to cut back on the work, and you decide where in that realm of lots of work down to no work shown you are, because I don't need to see the work for this, okay? So, for example, what we're doing here is plugging in to 4 minus 4 cosine here, right? That's the equation. And so I'm going to take out theta and plug each of these in. So I would have 4 minus 4 cosine of 0. So that's my first one. You can call it 0, you can call it 0 pi, it's the same thing, okay? Cosine of 0 pi is 1, right? So that is 1. Right here, right here. What do I do first? You multiply. We don't subtract first, okay? 4 times 1 is 4, and 4 minus 4 is 0. We have to know order of operations at this point in our life, okay? Keep on going. I'll do another one showing a lot of work. I mean, I hope you guys don't have to do this for every problem. I'm going to show you how to cut back on this in a minute. 4 minus 4 cosine, my next theta is pi over 3, okay? Cosine of pi over 3 is 1/2. So I have 4 minus 4 times 1/2. Half of 4 is 2. So I have 4 minus 2, or 2. Let me reiterate, I do not need to see this work. As much as you can do in your head or shortcut it is fine with me. Next, let's just cut back on the amount of work. I know I'm going to have 4 minus 4 times something, right? The whole time. 4 minus 4 times something. What is that something? Cosine of pi over 2. Just look here. Just grab it right from here. 0. 4 minus 0 is 4. 4 minus 4 times something. That something would be cosine of 2 pi over 3. Denominator of 3 is going to be 1/2. I'm in quadrant 2. Cosine is negative. So that's negative 1/2. So be careful here, my little algebra students. A negative times a negative is positive. So this ends up being 6. Okay, this is annoying, right? This is an annoying amount of work. You know, 4, 6, 8, where's my key? I'm just cutting back on it right now. 4, 6, 8, 6, 4, 2, 0. You should get a very symmetrical chart. Notice everything's positive. Like I was building 0, 2, 4, 6, 8. You're not going to go like negative 17, okay? It should make sense. And there's going to be another situation where you're going to be able to tell if you did it right or wrong, and I'll show you right here in a second, okay? So try to see the pattern, cut back on your work. If you try and do, guys, if you try and do this level of amount of work for every single problem, you're going to take the whole period to do that, okay? So find some ways to go through it a little bit quicker. And I think this is very helpful. But you do you. Boo. Okay, I completed the table. Now I'm going to sketch the curve. These are all positive r's, so there's no shooting through the origin. All positive angles, no crossing. We are going to go out to all of these angles at exactly the number of circles it says. And remember, we're using the quadrantals and our denominators of 3. You do not need to take the time to label this tomorrow. I'm just doing it to remind you that your denominators of 3 are the angles that are by the y-axis. Don't confuse that. So again, you do not have to label this for me. Okay, so the quadrantals and there. And then just put your points on there. 0, 0. Pi over 3 will go out 2 circles. pi over 2, 4 circles, and so on. I'm going to show you right here. I made a mistake earlier, and as I was doing it, I didn't even pick up on it, but look what I did, and I'm going to put it in pencil, so don't make this mistake. I went to 4 pi over 3. Instead of 6, I went out 8, okay? So I'm going to do that again so you can see how I was able to catch a mistake I made when I went to go connect these. So this is wrong. That's why it's in pencil. 3 pi over 2 is at 4. 5 pi over 3 is at 2. Okay? So when I went to connect these, now listen, did they go out too far? Yes. See? Again, I just made another mistake, not on purpose this time, and I noticed it was not symmetrical. This one was too high up. I went out an extra line, okay? You may not know if this is a heart, if this is a loop, if this is a dimple when you first start the problem, although you might know how to figure that out. But remember, I told you that's not the most important part. But you should be able to connect these, and it ends up making a heart, okay? If it was a loop, this point would be further down here, and you'd make a loop down here. If it was a dimple, it would be up here somewhere. Now, do you guys see how my graph, it's not just my normal not doing a good job with graphing. It looks, something's off, like it's got a little something. So when I saw this earlier, I was like, oh, wait a second. I went out to 8, and I should have only gone out to 6. So I could fix it, and there we go. So sometimes you can catch a mistake, whether it was in here or on here, by your graph too, okay? Now, are we good on that part, guys? All right. In the next section, it's identifying the extrema of the function. We definitely talked about the max, and we have been talking about the min, but we were calling it the zeros. So let me get to that in a second. Your max on a polar equation is the point furthest away from the pole, okay? Let me just tell you why I'm saying that. Back in the beginning of the year, we were talking about parabolas and their characteristics. A parabola has a min at the bottom of its graph or a max at the top, okay? So it mattered where it was in relation to all the points. Min was at the very bottom, max was at the very top. Polar has a little bit different, why wouldn't it be? And it's the point furthest away. It doesn't matter what direction it's in. It doesn't matter if the R is negative, it's the absolute value. So you can, I hope, tell that this is your max because it's the point furthest away, but you also have a table of values. Which point has the biggest R? That would be this one. And the way we name a point is R theta. So remember, your ordered pairs, alphabetical order, by the way, just like X and Y, cosine and sine are alphabetical order, R, and this is, some of you have been saying it wrong, but it's a T, that's how you spell it, theta actually, but R comes before T in the alphabet, okay, so R theta. Yep. You can. I can tell by looking at the graph, but that point also matches up with this point here. It doesn't matter. It doesn't matter. Is that how you graphed it here? No. Okay. So in the min is where your R's are 0. Okay, we just called them the zeros before. And again, you can just grab them right out of here. Oops, sorry, that's 0. And 0. So even though this table was a little bit of work, annoying, not difficult, the whole rest of this paper, we are using it to answer the question. So it's really helping us get through all this. Because look at the next one. Where is F increasing? Where is F decreasing? I've been telling you, it's easier to evaluate these graphs if you put them in rectangular form. I would have said, oh, pick up your calculators and put it in rectangular form. It's so much easier. But you're not allowed to use a calculator. But guess what? You can maybe tell by looking at this, although it's not my favorite thing to do, but you can tell by looking at the numbers in your table of values. From 0, 2, 4, 6, 8, we are increasing, right? And then 8, 6, 4, 3, 2, 0, we are decreasing. So from 0 to pi, our graph is going up. From pi to 2 pi, our graph would be going down. Again, it would be so much easier if we had this in rectangular form, but a table of values is just as easy. Numbers going up, the graph is going up. Numbers are going down, the graph is going down. And if you weren't here yesterday, we did change this to say find the average rate of change and crossed all that out. So if you weren't here yesterday, make that change. And this is the AROC. What we have to remember for AROC is change in R goes on top, change in theta goes on the bottom. Think of that as the same order as the ordered pair. We put R first, R on top. So I'm going to subtract the R of pi by the R of 2 pi over 3. And back up to my table of values, I have those R's already done. I already did the work for that. The R for pi, so I'm looking at these 2 points right here. The R of pi is 8, and the R of 2 pi over 3 is 6. And then stay in that order, okay? So I went pi on first and then 2 pi over 3, so keep that order in the bottom. Eight minus 6 is 2. I need a common denominator here, which would be 3. Right now, pi has a 1, right? Pi is the easiest one of all of them to get a common denominator. 3 over 3 is 1. If I wanted a denominator of 4, it'd be 4 over 4, and so on. 2 over, when I subtract these two, I get pi over 3. Keep, change, flip. Keep the numerator, change division to times, flip the bottom fraction. And this is just multiplication straight across. There's your answer. Okay? So your FRQ on the test is going to be exactly like this, just a different graph. Okay? Two pi, where, like here? Anytime your R is 0, you're at the pole. So that means you go out how many circles? 0 at 2 pi, which is over here. So just right there. Anytime you have an R of 0, that pole doesn't even matter what the theta is, it's right here. But we just easily grabbed them right out of here. We did the math of it, so we have it right there. Opening up to any other questions. Go. You better. I'm recording this. Your fellow students in other classes are counting on you guys to ask good questions so they can learn from it. 10? You say 10? Oh, what number did you want? There could be. I don't remember there being that, though. Okay. I mean, could you get a negative R? Yes. What would happen differently here? When you graph it, you have to shoot through the origin. So, for example, if you had 4 pi over 3 negative 6, remember, you go to where 4 pi over 3 is, which is quadrant 3, right, because it's one more on top. So 4 pi over 3, I would go out, where am I, 6. So I'd hover there, and I'd say, do I get to stay here? Yes. Okay, I do if it's positive, like I did. But if it were negative, I would shoot through, and it would end up over here. That's the only difference. Okay, Sydney? I'm sorry, I couldn't hear you, sweetie. What? I don't, no. I would count on this being a dimple, a heart, or a loop. Without a calculator? No, you do not. You in fact will not have any FRQs with a polar equation. I'm just doing that to you, okay? I just do it. But no, you will not have to do any polars by hand. Okay, someone asked for number 10, so let me do number 10. Oh, great question. Because here we have, and we're in the graphing calculator portion, although we don't need it for this part.
All right, Countryside High School, thank you so much for your cooperation. We are now, the warning has been lifted. We are now in the thunderstorm warning. Due to how rapidly weather can change, just stay alert. We will continue to monitor and alert you if we need to go back into our duck and cover. Please maintain all normal operations, except for any outside activities at this time. Stay tuned regarding the extracurriculars for after school. Right now, everything is still on.
You okay, Top You okay? All right. Need a hug? You doing okay? Okay, good. All right. I just want to make sure you're okay. Your mental health is important. Okay, so here we go. Here is a polar equation, but it doesn't look like a polar equation. That's because it's graphed rectangularly for us. Okay, so listen. If you skim through the choices, there's some questions about extremum, so like min, max, that's what that is, and then positive, increasing, negative, decreasing. So looking at your choices, the answer is A, but let's kind of break them down. A is the farthest. I feel like that should be this. Do you guys think that? I'm having a hard time with them writing farther. I feel like it's furthest. I don't know, whatever. The graph will be the furthest from the origin at 7 pi over 4 when it reaches its extremum of the absolute value of negative 6 or 6. That is the truth. That is our maximum point. It is the furthest away from the pole, which we think of as the x-axis, and the absolute value of that, negative 6, would be 6. And it does happen at 7 pi over 4. How do we know that? It's because we're halfway between 3 pi over 2 and 2 pi. This is the one I worry that you guys would think it was, this point here. Because you think, like, even though it doesn't say maximum, I think we think of extremum or extrema as a maximum mostly. And we think, oh, because it's at the top, like a parabola, that would be a maximum. But remember, in a polar equation, it's just the one that's furthest away. We were able to tell it numerically here, okay, and here it's visually. And then these two won't match up if you look at them at pi, positive, at pi when as positive and increasing will be far. I don't even think that makes any sense. We haven't even talked about something being farthest from the origin. What we have said is moving further away, right? The distance is increasing, not it's the furthest distance from the origin. Well, that doesn't even make sense. Oh, I think they're trying to mix. They're trying to mix in maximum or minimum with our language from yesterday. Okay, so that's A. Does that make sense? Okay. Yes. Number 9 and number 7, great problems to talk about. They kind of go together. This is a polar equation, and we need to evaluate what's happening with the radius and if the graph's going up or down. So this has to do with those characteristics matching up. If we're positive and increasing or negative and decreasing, we are moving further away, or our distance is increasing from the origin. So I would say to you guys to clear your RAMs when you first get your calculators and just be in rectangular mode the whole time. I can't think of any reason you would want to be in polar mode, even though it's a polar equation and we're talking about it like a polar equation. We learned that if we put it in our calculator in rectangular mode, it's so much easier to evaluate what's going on with the points. And when you clear your RAM, remember, that puts you in radians, which you always want to be in, and it puts you in rectangular form automatically. So you just clear your RAM and put your y equals in. Don't let it bother you. That's an X and that says theta. It doesn't matter, okay? Other thing, I'm not wasting time. I don't care what the graph looks like right now. I want to answer the question, so I'm going to also change my window. Fix this right now. I'm going to change my window to 0 to 2 pi. So go to window. My x min would be 0. My x max would be 2 pi. If you really wanted to evaluate the table, which I'm going to show you in a second, isn't really necessary, you could change how you change the table. Remember, table set, and change the 1 to pi over 6. But that part is really optional because you're going to be able to answer this question without using the table, just by looking at the graph. Okay? Did I not change my window? Oh, yeah, okay. No, I did. So here's the graph of cosine going up 1. So it's a amplitude of 2, up, middle, down, middle, up, all the points moved up. That's what you're seeing there. Okay? So let's look at our choices. We're evaluating something that happens at this interval or something that happens at this interval. Well, I could probably figure out what all these little tick marks are on my x-axis, but why not use the really cool capabilities of our calculator and zero in first on this one and then on this one. So go back to your window and change that to 3 pi over 2 to 2 pi. So what I'm doing here is zooming right in to that part of the axis. Okay, so 3 pi over 2 to 2 pi. And then you kind of see what almost looks like a line with a slope. It's just because it's super close up to it, okay, not zoomed out where you can see the curves. So what we're answering is R positive or negative, and is it increasing or decreasing? So are these points positive or negative? Positive, because they're above the x-axis. Well, look, they didn't even give us that option. We are increasing, okay, but we're not negative and we're not decreasing. So we can eliminate those two right away. Change your window one more time. Arlen, were you the one that asked me about this? Are you with me? I just want to make sure. Okay, so 0 to pi over 2. I'm going to look at what that one looks like. Okay, these are above the x-axis, so positive, right? So it could be either of those for that, but are we increasing or decreasing? Decreasing. The points are going down. Remember how I said it's optional to change the pi over 6? If you want to look at your table and go to 0, which is where I am, you can see the numbers are getting smaller. So if you had trouble reading the graph, I don't think you would, but you could also look at it numerically. So we are positive and decreasing, so our distance is increasing, okay? Or decreasing. We are positive and decreasing, so our distance is decreasing. 7, let me just throw 7 in with this, right, because it's the same type of problem. Again, rectangular form is so much easier. You can just clear it out, sine x, close your parentheses. I'm going to be looking at pi to 3 pi over 2. I'm not wasting time. I'm going to go right to my window and change it, so I'm not waiting for my calculator to finish graphing before I can go change something. Let's set it up for success right in the beginning. Second pi, and then 3 pi over 2. And let's see what's happening right there. Well, without even reading the question, I see I'm negative and decreasing. So my distance is increasing, right? Or getting further away from the x-axis. So looking at all these, below the x-axis, where's the graph below? Okay, so we know it's not these two, above, right? 50-50 chance at this point. And moving farther away or closer to the origin. This kind of goes by what you were saying yesterday, Ty. I don't remember, like we kind of chat about it. But, I mean, are we moving closer to the origin or further away? Further away, right? We're moving further away. The distance is increasing. We're moving further away. Distance is increasing. It shows what? So it did a phase shift. It moved all your points left one instead of down one. So just learn from Ty's major mistake. If you don't put the parentheses, your graph is different. Okay? This is moving your points down one. Without the parentheses, it moves your graph left one. Okay? What's next? 2. All right. So if I sketch where this graph is, 1, 2, 3, it would be right here. That's where this point is. Okay? So I'm going to call it P. Now, I have to decide which one of these is not at that same spot. So if you were just going to kind of go in order, there's some more test-taking tips here for you. The minute I get to this one, I'm like, it's not on the unit circle. I have to do a little math problem to figure out where this one is. Let me save that one for later. Maybe, I'm running out of time, maybe, I don't have to deal with that one. I will, but I'm just trying to help you guys think about how to do this tomorrow. So when I go to see where these guys are, I'm going to go to where they would be positive, okay? And then I'll move according to where the negatives are. So 5 pi over 3, that's quadrant 3, okay? And out 3 circles. So I'd be like in the middle right here where I'm hovering, but I don't get to stay there because the radius is negative. So I would shoot through the origin and I would land right here. So B is also at that same point. So can't be this one. Let's do this one. I'm going to go to 3 pi over 4, which is right here. 3 pi over 4 is right here. I have 2 negatives. I can either shoot through the I can either shoot through the origin, cross the x-axis, or I can cross the x-axis and shoot through the radian. Shoot through the origin, sorry. So remember, when r is negative, you shoot through the origin. When your theta is negative, you cross the x-axis. Either way you look at it, you're going to end up right here. There's my answer. But just to be sure, let's do a quick check of these. 3 pi over 4, positive, would be where D is. Both negative. Shoot and cross. There is C. Okay? So it can't be that one. And let's go back to this one, because let's just pretend you didn't, maybe that's the answer. I don't know. We know, but whatever. I would have to figure out what this is on the unit circle. This is greater than 8 pi, or 2 pi, 8 pi over 4. So it's off the unit circle. To find its coterminal angle, I'm going to subtract 2 pi, which is 8 pi over 4. That's how you make a number. So pi over 4. So 9 pi over 4 and pi over 4 are at the same exact spot. So you would also have point A right there. Okay? This is what I'm checking, but I can do it super quick. I'm not even going to bring my notebook. I'm going to come around and just do a quick scan so I can answer questions. So just figure out where it is for me. Who has another question? Remember, I'll take late homework for half credit if you don't have it. Sydney, what number? Oh. Oh. It looks like your flashlight was on. Last minute questions. Y'all better get 5 right. That's a freebie. Right? That's a freebie. To the left on the cosine axis, negative cosine. Anybody have a project to turn in to me? I will take it. Good job, Arbor. All year. Mm-hmm. Okay. But it was already late at that point. Are you arguing me over a point? That wouldn't have made a difference. Homework doesn't count that much. I win.